Good morning, my friends. We're going to be taking a look at problem number 5.27 this morning. The problem statement in 5.27, find the reactions at point C and the tension in cable T. I started the free body diagram. So I've got the two indicated weights at point A and point B. I've shown the reactions for the support pin at point C. I'm going to add something though that we're going to need. Let me get a different color for it so it stands out. So the tension in cable T comes in off an angle theta. So at some point it's my belief that we're going to need to break that into an X and a Y component. So I'm going to go ahead and put that on my free body diagram as tension in the Y direction and tension in the X direction. I do notice that there are a couple things that are missing from my free body diagram that I'll go ahead and include. So for example, the distance from point A to where the cable attaches is 1.2 meters. The distance between where the cable attaches and point B is 0.3 meters. And from point B to point C is 1.5 meters. And then this distance from the pulley to point C is 2 meters, which is very important because that's going to give us theta. So I'm going to go ahead and draw us a little triangle over here. Oops, that's not. You guys deserve something a little bit neater than that, especially if I have the ability to draw straight lines. There we go. All right, pretend that's the right triangle. 2 meters, 1.8 meters. Here's my theta. Theta is equal to inverse tan of 2 over 1.8, which I think is equal to, well, I don't have to think. I can look on the calculator. 2 divided by 1.8. Ah, yes, 48.01 degrees. So theta is equal to 48.01 degrees. All right, so I think that we have, well, if we were sitting in class, I would tell you, I'm not sure if we're going to need this theta or not, but go ahead and get it just in case. All right, so this boom, AC, is at equilibrium. So that sends me through the equilibrium equation. So let's see what we've got here. I'm going to start with summation of forces in the X direction. There are two of them. The X component of the cable in tension minus CX, which is equal to 0. That doesn't give me anything. Summation of the forces in the Y direction. We've got negative 35 kilonewton force. We've got Ty going up. We've got the force due to weight at point B, which is the down direction, so minus 50 kilonewtons. And we've got a positive force in the Y direction at point C due to the reaction at point C. Combining those terms are like negative 85 kilonewtons plus Ty plus Cy is equal to 0. I'm going to go ahead and rearrange this to get the variables by itself by adding 85 kilonewtons to both sides. Because I know that eventually, as we've seen in the other problems, we're going to need that. Right, so still have not solved anything. Let's take a look then. So we only have a couple other choices, and they all rhyme with, let's take the equilibrium equation of moment about a point. So I'm going to work this one as a summation of moments around point C. Doing so eliminates CX and CY from the moment equation. So let's see how that works out. So B, the force at point B is a player. It's a 50 kilonewton force, and it is 1.5 meters away from point B. Perpendicular distance between the 50 kilonewton force and point C is 1.5 meters. TX is not a player. Notice the TX, the force TX is directly through the line of action at point B, or I'm sorry, point C, not a player. TY is a player, however. So TY, and it has a perpendicular distance of 1.8. So the distance between TY and point C is 1.8 meters. And then finally, we have my good old friend over at point A, 35 kilonewton force. It is 3 meters away from point C. We do the arithmetic. 50 times 1.5, I think it's 75 kilonewton meters, plus TY times 1.8 meters, plus 35 times 3, which is 105 kilonewton meters, equal to 0. Combine those terms, they're like 75 plus 105 is 180 kilonewton meters, plus TY 1.8. Oh man, you know what we forgot to do? Well, not we, me. I forgot to take into account the directions, so I apologize for that. Let's go grab those real quick. If I'm taking the moment about point C, 50 creates a counterclockwise, which is positive. TY creates a clockwise, which is negative. A creates a positive, a counterclockwise, which is positive. That was positive, negative, positive, positive, negative, positive. Oh, so I didn't mess this up too bad. Equal to 0. All right. Add TY times 1.8 to both sides. You get 180 is equal to TY times 1.8 meters. Divide both sides by 1.8 meters. And you get the TY is equal to 100 kilonewtons. It is positive, which only means that I have gotten the correct direction of TY. So we can go up here into the summation. I'll go ahead and circle that. We might need that in a little while. Going back in, substituting that into summation of the forces in the y direction. 100 plus CY is equal to 85. That's 100 kilonewtons and 85 kilonewtons, by the way. Subtract 100 kilonewtons for both sides. You get that CY is equal to negative 15 kilonewtons, which is an indication that I have guessed or assumed the wrong direction for CY. So I'm going to rewrite it as CY is equal to 15 kilonewtons, and it is going that way. Since it is negative, that tells me that I have guessed the wrong direction. I had assumed that CY was going to be going upwards. I got a negative value, which is an indication that the assumption was incorrect. Assumption was incorrect. So that takes care of TY and CY. Does not take care of TX and CX, however. But I do know, I mean, it is a fact that we have a triangle and theta was 48.01. TY was 100 kilonewtons. We can use that to find T. We can use that to find T and TX for that matter. Let's see here. Let me go over here where we've got room. Sine, cosine, tangent, opposite, adjacent, opposite over adjacent. I think you've probably seen me do this in class more than once. I can use sine 48.01 degree is equal to 100 divided by t. Therefore, t, I think if we do this, t comes out to be 134.54 kilonewton. That does answer the bell for cable tension. Now, to find CX, which was the other thing that we need the value for TX. So TX, we can use cosine 48.01 degree is equal to TX divided by 134.54 kilonewton. And if we do the arithmetic for that, I have the TX is equal to 90 kilonewtons. That one's very important for us because we said that the summation of the forces in the x direction was Tx minus Cx, Tx equals 0. 90 kilonewtons minus Cx equals 0. Therefore, Cx is equal to 0. I'm sorry, therefore Cx is equal to 90 kilonewtons. So I'll put it all together over here for us. Cx is 90 kilonewtons. Going to the left, Cy is 15 kilonewtons going down. And the tension of the cable is equal to 134.54 kilonewtons at an angle of 48.01 degrees. Have a great day.